Now let's continue another interesting debugging practice about the privilege mode. So in this lecture, we're going to see how the privilege mode switches from supervisor mode to the machine mode. Now first observation will be the current privilege mode. Now the current privilege mode is the user mode. So for the experiment, I will change the switch the current privilege mode as supervisor mode. So please take a look at this. The address starts with SP. This means that current privilege mode is the supervisor mode. Now let me run this assembly instruction again. Now it's about to run a call assembly instruction again. And a call assembly instruction calls the trap. When the trap happens, RISC-V core to do the two things at the same time. First, it will jump onto trap vector base address. Second, the privilege mode can be switched. Now, I will run this instruction to see which value will be updated in the MPP field inside the machine status register. So I will run this instruction by choosing step button 1, 2, 3, and pay attention to the MPP feed bit field along with this information. Okay, let me go ahead. Please take a look at this. MPP bit field is updated to supervisor mode. Please take a look at the supervisor mode, and the current privilege mode has become the machine mode. Now the parent counter is indicating the trap vector base address. The second observation can be done. An interesting observation is that in MPP bit field became another interesting some information, that is this information. So MPP field indicate the previous privilege mode. Now at the moment it is updated to 0, 1 value. So another information is that there is an important crucial software, some stack software layer, that is OpenSBI. OpenSBI is most important firmware layer available in the machine mode. When the supervisor mode wanted to have critical information, a call assembly instruction should be performed to get into the machine mode. Reason is to retrieve the critical information. The OpenSBI should be implemented in any of the RISC-V based system. Moving back to the main topic, please take a look at this. Now you can see the MPP bit field is updated to supervisor mode. Now let's do another interesting debugging. Run this assembly instruction. So at this point, we are about to read the value of mstatus register at this point. Now, the current value of the machine status register is displayed like this value. After we run this instruction, you're going to see that S1 register, here it is. S1 register is one of the general purpose register in the RISC-V architecture. So if I run this instruction, you can see that S1 register is updated to the value of this one. Here we go, 1, 2, 3. Please take a look at this. Value of the S1 register is updated. This comes from this value. So whenever you look into any of the trap handler and you're going to see those kind of assembly block, because this information is important to identify what happened at the moment of trap. For example, it will let us know the previous privilege mode depending on this information, and control move to another function. Take for example, if the previous privilege mode was the user mode in this case, and the corresponding system call handler can be implemented in the user mode. If the previous privilege mode was machine mode, and sort of the interface for OpenSBI, and should be called because previous privilege mode was supervision mode. Now we perform interesting debugging practice. The next lecture, and you're going to see another interesting debugging practice, that is user mode to the supervisor mode. There will be another interesting debugging practice.